Example 2. Suppose a ball is dropped from the height of 200 feet. Its position at time t is s of t equals negative 16t squared plus 200. Our goal is to find a time when the instantaneous velocity equals the average velocity. Let's understand what the problem is asking. Instantaneous velocity is the derivative, which is s prime of t. Average velocity is the average rate of change over an interval. So we are looking for a time t where the instantaneous velocity equals the average velocity. Since the question does not give us the interval, so we need to identify the interval first. The ball starts with the height of 200 feet. So the moment when you start dropping the ball, that is when t equals 0 and the height is 200 feet. So we need to find when the ball hits the ground. When the ball hits the ground means the height is 0. So we let s of t equal 0 and we solve for t. S of t equals negative 16t squared plus 200. So I have the equation negative 16t squared plus 200 equals 0. To solve for t, I first subtract 200 from both sides. So I get negative 16t squared equals negative 200. And then I divide both sides by negative 16. So I get t squared equals 200 over 16. And 200 over 16 is 25 over 2. Next, we take the square root of both sides of the equation. So I have t equals plus or minus square root of 25 over 2. Since t represents time, it cannot be negative. So we only keep the positive value. So t equals positive square root of 25 over 2. Or 5 over square root of 2. So our interval is from 0 to square root of 25 over 2. Step 2. We need to check the conditions. We want to know if s of t is continuous on a closed interval from 0 to square root of 25 over 2. And we want to know if s of t is differentiable on an open interval from 0 to square root of 25 over 2. Since s of t is a polynomial, and polynomial is continuous and differentiable everywhere. So yes, s of t is continuous and differentiable on the given interval. So the mean value theorem applies. Step 3, we need to compute the average velocity. I use the formula S of B minus S of A over B minus A. A is 0 and B is square root of 25 over 2. So I have S of square root of 25 over 2 minus S of 0 over square root of 25 over 2 minus 0. Since S of t is negative 16t squared plus 200, so S of square root of 25 over 2 equals negative 16 times square root of 25 over 2 squared plus 200. And S of 0 is negative 16 times 0 squared plus 200. And over square root of 25 over 2. And negative 16 times square root of 25 over 2 squared plus 200 is 0. Negative 16 times 0 squared plus 200 is 200. So I have negative 200 over square root of 25 over 2, which is negative 200 times root 2 over root 25. And root 25 is 5. And 200 divided by 5 is 40. So I have negative 40 times root 2. So the average velocity equals negative 40 times square root of 2. Next, we are going to find the derivative of S of t. S of t equals negative 16t squared plus 200. So S prime of t is negative 32t plus 0, which is negative 32t. So this is the instantaneous velocity, and this is the average velocity. Go back to the question. The question wants me to find t when the instantaneous velocity equals the average velocity. So next, I let S prime of t equals the average velocity, and then solve for t. I want to set S prime of t equals negative 40 times root 2. And S prime of t is negative 32t. To solve for t, I divide both sides by negative 32. And negative 40 over negative 32 is 5 over 4. So I have 5 times root 2 over 4. So when t equals 5 times root 2 over 4, the instantaneous velocity equals the average velocity. So this is around 1.77 seconds. Notice that I kept everything in exact form the whole time. Since the question does not ask for an approximation, we leave the answer exact. Even if a question does ask for a decimal, you should still keep everything exact during your work and only round at the very end. All right, let's finish this section by looking at some important results from the mean value theorem. The first one, functions with a derivative of 0. If the derivative of a function is 0 for all x, then the function must be a constant. What does this mean? If the slope is 0 everywhere, the graph is completely flat, so the function never changes. It stays the same value. The second result, constant difference theorem. If the two functions have the same derivative, meaning f prime of x equals g prime of x, then the functions differ by a constant. So f of x equals g of x plus c. And c represents a constant. For example, if f of x equals 3x squared, then the derivative f prime of x equals 6x. If g of x equals 3x squared plus 100, then g prime is also 6x. So f prime equals g prime, but f of x does not equal g of x. They are differ by a constant. So if the two functions have the same slope everywhere, they are basically the same graph, just shift up or down. And the third result, increasing and decreasing functions. If a function is continuous over the closed interval from a to b, and differentiable over the open interval from a to b, then if f prime of x is greater than 0, which is the derivative is positive, then the function is increasing. If f prime of x is less than 0, which means the derivative is negative, then the function is decreasing. Let's connect this to the graph. On the left side, the derivative is positive, so the function is increasing. In the middle, the derivative is negative, so the function is decreasing. On the right side, the derivative is positive again, so the function is increasing again. So remember, positive derivative implies function increases. Negative derivative implies function decreases. Now that we have covered the main ideas and examples, let's finish with some key takeaways. For the Rolle's theorem, the derivative equals 0 at some point. For the mean value theorem, it connects the average rate of change and the instantaneous rate of change. Mean value theorem guarantees a point where the tangent slope equals the secant slope. If the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. If the derivative equals 0, then the function is constant. The mean value theorem helps us understand how functions behave, connects different types of slopes, and gives us powerful tools to analyze graphs.